All right, so what we're going to be looking at is controlling the amount of products in a chemical reaction. And this is what we did before we actually went ahead and did the lab in class on our second day of UMSL Bridge for ninth grade science. Okay, so I'm going to be starting right over here where it says any chemical equation has an input and an output. In chemistry, input is called a reactant. Reactant molecules are broken down and rearranged to result something new. Reactants can always be found on the left side of the chemical formula, the output, the resulting molecules after the reaction has taken place. And they are called the products. Okay? So reactants are the input, products are the output. Okay, look at the following chemical equation for the reaction between vinegar and baking soda to answer the following questions. Okay, and what we get here is we get a chemical formula right here. And we also have a couple questions here that say circle the reactants. Okay, the reactants are going to be anything on the left side of the dash line that I drew. So that's going to be the acetic acid and the sodium bicarbonate. Okay, and then underline the products. The products are going to be the things on the right side of the arrow or the dash line that I made. So sodium acetate, water, and carbon dioxide. Okay? So both of these we've taken care of. So I'm going to go ahead and cross those out. Okay. How many of each type of atom appear on each side of the chemical equation? Okay, so one thing I want to quickly just go over is when it comes to carbon, hydrogen, oxygen, and sodium, they have acronyms that represent those elements. So for carbon, it's going to be like C. Okay, hydrogen, it's going to be H. Oxygen, it's going to be O. And sodium, it's going to be Na in parentheses. Okay. What we're going to want to do is we're going to count on the reactant side, on this side here, how many of each of those there are, and then we'll do the same for the product side. Okay. So I'm counting C's that are in this side of the equation here. Okay. And first C I find is here. So C with a 2 on the bottom of it. Then I find one over up in the front over here as well. Okay. And if there is 2 with this one and then 1 with this one, that's going to make a total of 3. Okay. Then for the hydrogen, I'm going to find this here. Oh, let me zoom in a little bit. So we got H4 there, and we have a H with no number. That means it's a 1. So we have 5 total, because 4 plus 1 gives us that. Okay. Mhm. All right, our next one, oxygen. So oxygen, we have 2 there. And we have 3 there because of the subscript there, the numbers on the bottom right of it. Okay, and 2 plus 3, that's going to give us 5. Okay, let's see, now we have one more, and that is sodium. That is Na, so I'm going to look for Na, and I only have one of those, so I'm just going to write 1. Okay. Now we are going to look at the product side. So on the right side, all the way here, we're going to see how many of each of those we have. Okay, and this is after the chemical reaction has occurred. Okay, so we'll start with C's again. So we got C's right there, and I got a C there. Okay, so that's 2 plus 1. It's going to give us 3 carbon. Okay, and then let's see, I could do, let's see, erase that. Okay. Next one is H. Okay, I got 3H there and 2H there. Okay, that's going to give us a total of 5 hydrogen. Okay. If I continue, I'm going to have O's that I'm going to be looking for. Okay, so I'm scanning it through. I find O there, and a couple O's there. So that's going to be 2 plus 1 plus 2. So that should give us 5. Okay. Then the last one we're going to look for is how many NAs do we have? We actually only have one, so I'm going to go ahead and put in 1. Okay. And now at the very end, the part of the question down here is cut off, but what it says is, what does the statement mass is conserved during a chemical reaction mean? Okay. What it's showing is between this side and this side, the reactant and product side, it looks like they're the same on both sides. Okay, so before and after the chemical reaction, there were the same amount of atoms before and after. So what that means is all of the mass that's in atoms is conserved, meaning that nothing was created nor destroyed. And that's what happens in chemical reactions. Nothing is ever created nor destroyed. Okay, awesome. And even if you were absent, you would still print this page out, turn it in on Canvas, and submit it as a file once or you could submit it in person to me on the next UMSL Bridge day that we have. But this will be for a grade. Okay, even if you are not here for the experiment itself. Okay, awesome. Thank you.